include history, maturation, attrition, differential subject selection, repeated testing effects, instrumentality, mortality, differential attrition, regression towards the mean, and experimental bias. History: events that occurred outside the experiment between the two measurements. In an experimental context, it is defined as events occurring between the first and second or more measurements in addition to the experimental variable. In other words, has some event occurred to a subject or a group of subjects between measurements to confound the effects of the experimental variable or treatment. In such instances, the experimenter cannot determine whether the results is a function of the extraneous events alone, the extraneous events interacting with the experimental treatment, or the experimental treatment alone. Threats to internal validity. Maturation, which is changes within the subject themselves that may have an influence in the results of the experiment. Longitudinal studies are more susceptible to maturation effects. The effect of maturation is similar to the effect associated with history. History refers to events that occur outside the experimental setting and thus outside the control of the experimenter. Maturation, in contrast, refers to changes in subjects themselves that cannot be controlled by the experimenter, changes that may cause effects to be that are attributed incorrectly to the experimental treatment. Examples of maturational factors are age changes, changes in biological or psychological processes that take place over time, and the like. Obviously, maturation effects can play an important role in long-term treatment research. Attrition, also known as experimental mortality, the differential loss of subjects between comparison groups. Again, a common problem in longitudinal or survey studies. Subjects who fail to complete the research procedure may be quite different in important respects to those who continue, and the dropouts from the comparison groups may be due to different reasons. For example, the SLI group due to task is too challenging, while the TLD group due to the task is too boring. For longitudinal studies or treatment studies, at least try to collect the endpoint data. For survey, at least 50% of response rate is considered minimally adequate. 70% response rate is very good. Differential subject selection. Absence of equality prior to experimental treatment poses a threat to internal validity. Subjects have to be equal on important dimensions. For example, you need equal n's, equal number of subjects, equal amounts of treatment, equal tasks in both languages. The selection of persons to form experimental and control groups in experimental research can affect internal validity if selection is not done properly. Internal validity may be threatened because differences between the subjects in the experimental and control groups may account for treatment effects rather than the treatment itself. In most experimental research, one important requirement is that the subject should be equal on important dimensions before experimental treatment or manipulation. Repeated testing effects, or reactive pretest. Merely having been tested before will affect the performance on the same or similar subsequent task. Repeatedly taking the same or similar standardized tests are not made to be tested more frequent than once a year. The effect that merely taking a test may have on the scores achieved on subsequent administration of the same test. In other words, subjects may react to a pretest when taking a subsequent test. This effect may be due to the practice afforded by the first test, familiarity with the test items or format, reduction of test anxiety, and so on. For example, speech training effects was measured by a discrimination task. Pretest can serve as a training as well. Anytime pre-treatment tests are used, the reader must ask whether post-treatment changes are due to the treatment effects, testing effects, or a combination of the two. A solution is a control group without treatment, or a non-reactive measure. For example, a natural language sample, school grades. For reading improvement, collect a list of books that the child has been reading. Instrumentality: faulty, inadequate, or fluctuating calibration of the equipment used in the experiment. Appropriate calibration and ongoing monitoring of calibration are absolutely essential ingredients in the collection of valid data, whether the data are for research purposes or for clinical purposes. Although it is readily apparent that the mechanical and electrical instruments can be sources of error that pose threats to validity, it may be less obvious that such devices as rating scales, questionnaires, attitude inventories, and standardized language tests are also instruments, and that their use or misuse can have a profound influence on the adequacy of the data collected in either experimental or descriptive research. A poor pencil and paper test, one that has not been standardized, one that has inadequate reliability, or one that was standardized on a sample different from that under investigation, can have serious consequences for internal validity. Good questionnaire development is a very complex task, one not readily undertaken by a novice. It needs repeated pilots. Instrumentality includes different tape recorders, different sensor nets, different room settings, and even a different research assistant. Regression towards the mean. Extreme scores influence the results, the floor effect and the ceiling effect, a phenomenon in which the subjects who are selected on the basis of atypically low or high scores change on the subsequent test so that their scores are now somewhat better in the case of the lower scorer or somewhat poorer in the case of the higher scorer than they were originally. The investigator may conclude that the treatment produced the change when, in reality, the scores have simply moved or regressed toward a more typical mean score. That is, the scores have become less atypical. This occurs primarily because of measurement errors associated with the test instruments used in selecting and evaluating the subjects. An equally plausible explanation is that the improved scores simply represent statistical regression and that the atypical scores would have become more typical scores even without treatment. Experimental bias. Researchers may treat the data differently due to his or her own bias and perspective. You need a double-blind technique or cross-checking to counter against this bias. Experimental bias. Score differently if they know the participant's status. For example, you're more likely to score favorably on a TLD's test and to score more harshly on an SLI test. Doctors record the heart rate of full-term babies more accurately than preemie babies. Because a qualitative researcher serves as the instrument of data collection, researcher bias and subjectivity are inevitable and expected. It is also expected that the researcher brings a unique perspective to the study. Recognizing this inherent threat, Best and Kahn in 2006 suggested that a qualitative researcher needs to be reflective about his or her own voice and perspective when interpreting the voice and perspective of others. A solution: promoting redundancy and cross-checking. Interaction of factors is another threat to internal validity. The interaction among two or more jeopardizing factors.